Hey guys, today we're going to be making a procedural edge wear effect. This works in both Cycles and EEVEE. It is completely render engine agnostic, and it's pretty simple, and it's done using geometry nodes. This is the project file, which I will have available on my Gumroad. As you can see, it contains kind of two different use cases. Over here, we have just the simple edge wear effect, which is completely procedural and entirely based on the mesh. And on the other side, we have a use case that uses both the procedural edge wear mask as well as a height map to kind of add extra wear into the details that are purely texture based, which means you can take a textured object and use its textures to drive extra detail in the procedural wear. Let's go ahead and hop into a new blend file and look at how this effect works. Alrighty, to start off with, we're just going to grab a couple of objects so that we can see exactly what we're doing as we work. I've got this Derringer model, which I created. If you would like to buy the fully textured model, you can do it over on my Gumroad, or I will also include this version that you saw in the project file with both the height map and a normal map for free in the project file. So I'm going to get a cube and a Suzanne. On the cube, I'm going to go ahead and inset all of the faces by double-clicking I, and then click Alt-E to extrude along normals to just kind of give ourselves a little bit more of an interesting shape so we can see what's going on a little bit better. And then the Suzanne, I'm also going to go ahead and just add a single subdivision surface and apply it. Now, let's pull up this bottom bar sum, get ourselves a geometry node editor, and I'm going to go ahead and pull this out, and then click S to get ourselves a shader editor. We'll click New on the material, and I'm going to go ahead and hold Shift and select all of my objects and then click Ctrl L to link their materials so they all have the same material now. Then I'm going to click the New on the Geometry Nodes tab, and I'm also going to switch over to EEVEE so we can see what's happening. To start off with, let's go ahead and click Ctrl A and add ourselves a store named attribute node. We're going to name it Pointiness. You can of course name this whatever you want. Just make sure you can remember it, because we're going to need to type it in later. Then we're going to get an edge angle node. What this basically does is it looks at each edge with faces on either side of it and determines how steep the angle between those faces is. So to see what's happening, let's go ahead and plug one of these outputs into the value on the store named attribute, and then in the shader editor we're going to get ourselves an attribute node. In the name slot, we're going to type in pointiness, make sure the spelling and capitalization is exactly the same as it was on your store named attribute node. Then, let's plug color into color. And as you can see, Suzanne is looking different, but our other objects are not. This is because they do not have the geometry nodes set up. So let's shift and click on each of these objects, Ctrl L, and then copy modifiers. Now you can see it's working on all three of them. So you can see it's working very differently on all three of our objects. This is because it is highly dependent on the underlying geometry. Another thing we can note is if we switch between unsigned angle and signed angle, this is determining whether or not it checks if this is a concave or a convex angle. Signed angle will only include the convex angles, so the outward pointing angles, and unsigned will include both outward pointing angles as well as inward pointing angles. So things like this, where it's an inward pointing angle, will not be included on signed angle, but they will be on unsigned angle. For now, let's just use signed angle. Another thing you can see is that this goes all the way to the edges and there's not much detail. This is because it is highly limited by our geometry, because it is a vertex based effect, which means it is reliant on the existing geometry to know what's going on. To fix this and try and clean it up some, let's go ahead and drag out our group input, and we're going to add a subdivide node, as well as a subdivision surface node. Between these two, we can both add extra geometry as well as smooth our objects. For now, let's turn the level all the way down to 0 on the subdivision surface. In fact, we can even start kind of plugging it into our group input so we can control it from the modifier menu. Let's drag out first into our subdivide mesh and then into our subdivision surface on the level input. Then in the side panel, we're going to name the first level subdivisions. And the second one, smoothed subdivisions. And now, if we turn up the levels of subdivision, we'll notice that nothing changes. And this is because the order of operations is very important. Right now, we're checking our angles and assigning the attribute before we subdivide it, which means this node never gets to see the changes in our geometry, but it's very important we do this after we subdivide it. So let's go ahead and move it now. We'll just duplicate it, paste it over there, delete the existing one, and then replug in our signed angle into the value. And now you can see, as our subdivisions increase, the detail also increases. And now you can see it's actually detecting the division between these two different faces as we turn up the subdivisions. Another thing we can do is if we turn up the smoothed subdivisions, this will basically work exactly like using a subdivision surface on your model, which means we can add a couple basic subdivisions to keep the basic shape, because if we turn down our subdivisions and then turn up the subdivision surface, you'll notice it completely loses its shape. Whereas if we turn up the subdivisions first, we'll keep our initial shape while also smoothing it out some in the corners. Since we've plugged these subdivision values into our group input, we'll now need to change it for each model individually, but which also means we get individual control for each model. So let's go ahead and turn our smooth subdivisions up and our not ones down for this model, because I think that looks a lot better, and this model was made to be subdivided. Let's go ahead and even give it maybe 2 levels of that. And then on Suzanne, let's go ahead and turn down the normal subdivisions and turn up the smoothed subdivisions. We'll also go ahead and just shade all of our objects smooth. And now, to control how far this edge spreads between our edge angle and our store named attribute, let's add both a blur node and then also a map range node. The blur will just slightly smooth everything out, and the map range will give us control over exactly how it is clamped. Something else to be aware of is that as you add more geometry, it will also limit how far you can have these spread. So if you want them to spread more than just a tiny bit, you may actually need to turn down the subdivisions so that you can see they spread a little further initially. You can also try turning up the iterations on the blur, and that will spread them out as well, but this might get very performance hungry if you're doing too many iterations. Next, let's plug our mapping controls into our group output. So we'll just plug our 2min and 2max in, and now you can see they've shown up here, and we'll leave the rest alone for now. Let's go ahead and go mainly over to our shader editor. Let's also just select our most detailed model, and we'll kind of work on that so we can see how it works on a more complicated mesh, but it should work for all of them pretty much the same. The first thing we're going to want to do is remove some of how clean this is. So we can both adjust exactly how it appears by adjusting our 2min and 2max over here, or we can use a color ramp as it comes out of the attribute. And this option may be a little bit faster and a little bit more intuitive, but it also might have its limitations because it can only change the data you've initially fed it. That looks pretty good, so we'll stick with this for now as we move on to our next level of the wear. So this works well to find our edges, but it doesn't look very realistic for like grunge or rust or edge wear. So we want to kind of mess it up and make it look a little bit grungier. We're going to do that with some noise textures. Let's go ahead and create 2. One is going to be our slightly larger scale, and one will be our smaller scale. So the first one we'll leave at a scale of 5, and the other one will turn up to something like 40. Then we're going to get a mix color node. In the A socket, we want our edge wear mask, and in the B socket, we want our noise texture. Then we're going to change it from mix node to overlay. Then we're going to change it from mix mode to overlay. We can also use the factor instead of the color. Now, this is very hard to see exactly what that changed, so let's add another color ramp. We can just steal this one, reset it, and turn up the contrast of our noise texture to hopefully reveal a little bit better what it's doing. Now as you can see, it's sort of taking some of the bits and changing them up, but it's really hard to tell with this large of a noise texture. We can also turn up the factor so that it affects it a little bit more. Then we're going to duplicate our overlay and plug our second noise texture into the second slot of it. And now you can see it's doing a little bit more. And let's maybe turn up the scale a little bit on the first one to something like 10, and turn down the scale on the second one to maybe something closer to 20. What these overlay nodes are doing is they're basically only showing these noise textures where there is a grayscale gradient. So where it is black, it won't show them, and where it is white, it won't show them. They will only be revealed where there is a gray value in between black and white somewhere. So let's go ahead and add a color ramp onto the smaller noise as well. And as we drag it in, we can see we're really getting some like kind of realistic looking detail. We can also play around with the distortion and the other settings on our noise textures. I might turn the roughness up a tiny bit on the second one, but I'm going to leave it mostly the same for now, and then maybe lower the contrast on the second one. And you can see we're starting to really kind of get the effect of worn edges. But how do we actually turn it from just a black-white mask into a shader? And for that, it's pretty simple. We can mostly just use some color ramps. Let's start off by adding one for the main color. And for this, I'm going to be kind of making a painted metal where the black parts of this model are painted and where the white are sort of chipped, the paint is chipped off, and you're left with just the bare metal. For that, we'll take on our color ramp, we'll change the black to whatever value we want our paint to be. So for this, I'm going to go with kind of a desaturated, fairly dark red. We'll start with that for now. And the white, we're going to leave white. Then we'll duplicate our color ramp, plug our second overlay node into that color ramp, and then we're going to reset it. This second color ramp will be our metallic mask. So let's go ahead and plug the color into the metallic. And that made a very slight difference, but it's not quite contrasted enough. So let's go ahead and grab the white and drag it in. And as you can see, the bits that are white start to look more and more like metal as we increase this contrast. Then we'll duplicate it. Then we'll duplicate just the color ramp again, plug the overlay into it, and reset it. This will be our roughness, so let's plug it into the roughness. And for this one, anywhere we want to be the shiny metal should be black, and anywhere we want the flat paint should be white. So we want to actually invert this from where it is by default, because you can see the edges are currently white and the flat parts are black. So if we click this little down arrow, there's a flip color ramp option, and now let's drag in the black side until it's mostly covering where all of our edges are worn, and the white is where we want the paint. Now, if we preview the whole shader, the roughness is doing what we want, but it's way too strong. So let's click on the color in the color ramp, and we'll take the black and turn it up to sort of a dark gray till we get kind of a semi-matte chrome sort of look on our silver parts. And our white will make a tiny bit darker until we get just a hint of specularity on where we want the paint to go. And as you can see, this is starting to look a lot like what we want, but I think we might need to adjust these color ramps a little bit more. In fact, let's remove most of the contrast from the roughness one. I think that will look a lot more realistic. We can also tweak our metallic one, and let's change it from linear to ease. This will make the transition just a little bit smoother. At this point, we can add a bump node. This will help it look more three-dimensional and less like it's painted on. And as you can see, the effect is almost non-existent to begin with, and that's because the distance is probably set a little too low. So let's just turn it up very slightly till we start seeing the effect of it, and then we can turn the strength down to kind of dial it in. And I think at this point I might actually take the second noise texture and make it a little bit larger as well as the first one. We may also want to invert the bump so that it looks like these are chipped away instead of sticking out. And I think that looks substantially better. We can also adjust the effect using our color ramp. As you clamp it more, it reveals more of the worn metal, and as you clamp it less, it reveals less and less of it. You can also adjust it still using the 2 min and 2 max. Now, something else you may want to do is also detect the internal angles. And while you technically can do this with this very same effect, in fact, I have a little node set up in the project file for doing that. I wasn't very happy with the results, and I struggled to get it to look good. So if you want to see how that is done, you can see that in the project file. Basically, you just take the signed angle, because that tells you where the outside edges are, and you use the unsigned angle, which tells you where all the edges are, and you subtract the signed angle from the unsigned angle. Again, if you want to see exactly how I did it, you can check out the project file, but I'm not going to go too in-depth into that right now. For our purposes, the easier way to do this is simply use an ambient occlusion node in the shader. For that, we can either mix it in at the beginning. We don't really need to do that for this at the moment, so let's go ahead and just use a mix color node and multiply it over the base color. You may also wish to add yet another color ramp in order to clamp the contrast on that and make it more obvious. Now you can see it's kind of darkening our internal edges. You can also turn up the samples if you want it to spread further. And in theory, the only local checkbox should mean it only calculates the object for itself and won't shadow other objects. But as you can see, if we move these two closer together, it is still shadowing. So that may be a 5.0 bug. I'm not exactly sure. But in theory, that checkbox should stop that from happening. And now we have pretty much the entire basic edge wear effect. Something else you can also do is if you shift right click across many streams is combine them, and we can add a color ramp in right after our second overlay, and this will adjust all of the noise textures and stuff layered together before it gets pumped into all of our individual little tweaks, which means we can kind of change how the effect is revealed across the different noise while also updating it for all of our individual breakout things. Now I would recommend, if you're trying to go for a rusted, aged look, not to go so far that you start clipping out the noise, because that kind of makes it look too smooth. I may also make the shiny parts just a little more shiny. Now, this is pretty much the entire basic edge wear effect, but for additional detail, we can take the original textures from this model and mix them back in for extra effect. We're going to do this right after it comes out of the attribute node right here at the bottom, so that it goes through the entire process procedurally without having to tweak it for each individual layer manually. So let's add an image texture, and I'm going to use the height map from the original model. Now, if we look at it, you can see on the original model, these sort of floral details are recessed into the model, which means that they should be building up dirt and grunge, but because this is more focused on the external kind of edge wear, I'm not going to use them internal, and instead I'm going to invert it and have them poking out instead. So for that, I'm going to invert the height map, which you probably don't want to do on every model that you use, but for demonstration purposes, I'm going to do it on this one. Then we're going to add a color ramp, and really increase the contrast until we're kind of isolating the bits we want to actually add to the edge wear. And that looks pretty good. So we're going to add yet another mix color node, and we're going to put it right after the color ramp coming out of our attribute. We're going to plug our new color ramp into the bottom socket, and we're going to switch it from mix over to add. Now if we preview that, you can see we have both our edge wear on all of the edges, as well as we're starting to get kind of the height maps detailed blended in. We may actually want to increase the contrast on our height map a little bit. And since this is done before we get to our grunge, it means the grunge will actually layer over top of these new details we've added without us having to do any extra work. As you can see, these are kind of only appearing on some parts of the noise, and we can tweak this to our heart's content in order to kind of get it to mix exactly how we want it to. So if we preview the final result, you can see we're just getting little hints of it. Now, in order to make these details really pop and look correct, we kind of need the normal map as well. So I'm going to go ahead and take that and plug it into the bump node. And since we inverted the height map, it means we should kind of also invert the normal map in this particular instance. Again, this is more for demonstration purposes than something you should typically do, but we can do that by just simply setting the strength to a negative value. Now you can see they're kind of sticking out, and that looks a lot more correct for what we're doing. Let's also go ahead and just change exactly how it's mixed in. Maybe we want it to be a little bit stronger. And now you can see all of our nice little height details are also included in the edge wear without a whole lot of extra work on our side. I think this edge wear might also be a little too noisy, so I'm actually going to play around with the noise textures some more. I think that looks pretty good, but you could certainly tweak this more and get an improved result. Something else to note is, sometimes if you're getting these kind of internal angles which you don't think should necessarily be worn, we can subtract our ambient occlusion after we've added on the height map. For that, let's just go ahead and duplicate our ambient occlusion and use it again. We'll take a mixed color node, this time set to multiply, and multiply our ambient occlusion over our masks. And if we turn the strength up and maybe tweak some of these settings down, you can see we're kind of removing the wear from the really low points. Something else we can do is actually subtract the ambient occlusion from some of our other maps as well. For instance, our roughness should also be less shiny where there's more dirt and grime built up in the cracks and crevices. So we can duplicate our multiply node, put it on the roughness mask, and this time we're going to set it to screen because we want to make it brighter instead of darker. Then we'll take another color ramp. Then we'll give ourselves a little more room. Then we'll take another color ramp, plug our ambient occlusion into it, and this time we're actually going to invert it. If we look at what that looks like, now it's white in the crevices and black on the high spots. So if we plug that into the second option of this mix and preview it, I think we've gone a little too strong with it. But if we clamp it way down, you can see how our recesses and shadowed areas are brighter now, which will make them look less rough. I'm not going to do it in this tutorial, but you could certainly do the same thing on the metallic mask as well. And that's pretty much it for this tutorial. You can go ahead and grab, I think the project file, it looks a little bit better, as well as both the setup with the textures, as well as with just a base object that doesn't have any of the textures on it. If you want to help support what I do here, I also have a thanks page on which I sell minis that I've created. They can be used for Warhammer, or D&D, or just printing out to paint, or do whatever you want with them. Anyway, that's all I've got to say, so I'll see you next time. Bye-bye!